Okay, sorry for the weird angle. My phone died, so I need to use my iPad, and it's a whole thing. So I'm sorry that this is not quality video. But here's how you write the name to the formula for an ionic compound. Okay, so you'll be given a name such as potassium chromate, zinc phosphate, or nickel for, sorry, this should be sulfide. Okay, so the first thing you're gonna do, you're gonna make sure you have your nomenclature notes. Okay. I'm sorry, I hope you don't get like motion sick or something. So I'm gonna open up my notes, and right here it says writing names to formulas. Okay. And so the first thing I'm gonna do is I'm gonna write the symbol for the metal, and I'm gonna write the symbol for the non-metal or polyatomic ion. So in this case, I'm gonna do K, and then chromate is CrO4, and I know that because I memorized it, but also because it's on the back of your periodic table. Okay. Next thing you're gonna do, you're gonna make sure you write the charges for each of those ions. So potassium is in column 1 in the periodic table, right there. And so that's going to be a +1 charge. And then chromate on the back of the periodic table, right there, has a 2- charge. So I'm going to go ahead and I'm going to write 2-. Now, next step, crisscross the charges and reduce if I need to. Okay, so let me show you what this means. I'm going to take this 1 from the 1+ on the potassium, and I'm going to bring it over there, not the plus, just the 1. And I'm going to take the 2, just the 2, not the minus, and I'm going to bring it down here. And what ends up happening is we have K2, and then there's only 1 CrO4, so I can just leave it like this. If there had been 2 CrO4s, I'd put parentheses and then put a little 2 out there. But because there's only 1 CrO4, I can just write it like that. And basically what's happening there, the reason why we can do this little trick, is we're saying, okay, this is a potassium ion, and this represents a chromate ion. So how many potassiums do we need to have to be able to cross out that 2- charge? The answer is just going to be we need 2 of these guys to cancel out that 2-, because 2+ and 2-, they cancel each other out. Let's try another one. We've got zinc phosphate. So first we write the symbol for everybody. So we've got zinc and then phosphate. Again, we can look at the back of our periodic table and we can look for the name phosphate, and it'll tell us that it's PO4 with a 3- charge. But this one is difficult. This is a trick question, okay? Because zinc is a transition metal, you can't assume the charge for a transition metal. You can for column 1, 2, and 3. Remember, hopefully you guys wrote +3, +2, +1 on your periodic tables. You can't do that for over here because they can actually have different charges depending on how they're being bonded. So, how are we supposed to know that? Usually for those guys that are in the middle, they actually end up having one of the Roman numerals, but it just so happens that zinc is an exception. And zinc 2+ doesn't need a Roman numeral, so when you just see plain zinc, you can assume that it's +2. Okay? I know that that was complicated and probably dumb to do right now, but I wanted you to be aware of that. So again, you crisscross the charge. You take this 2 and you put it all the way out here. And you take that 3 and you put it all the way over here. And what ends up happening is we have ZN3 because we moved the 3 down. And then we have PO4, 2. If I leave it like this, this reads zinc 3, PO42. That's not right. We don't have 42 O's and 1 P. We have 2 PO4 ions. So we need to put parentheses around there. Similar to how you would put, like, in math, if you would go like this, 2 times x plus 5. If you write 2x plus 5, that's something completely different, right? Because this ends up going like that. It's kind of the same thing here. Okay? So that one would be happy. And again, if we know that zinc has a 2+ charge and phosphate has a 3- charge, how many of each are we going to have until they cancel each other out? And the answer is that least common multiple ends up being that there's a 6+ charge on this side and a 6- charge on this side, which means they cancel out. That's the whole point of all this. This crisscrossing is just a really easy trick to do, so I highly recommend using it. Okay, last one, nickel 4 sulfide. So again, first thing we do, we write out everybody's symbol. Sulfide is actually just sulfur with the fancy ending, because remember we changed the endings to "ide" when it's just a single non-metal for the ending. Okay, next we need to find a charge. So we were given a charge here for nickel. They told us that it was 4+ with this Roman numeral. IV means 4. And again, if you don't know your Roman numerals, it's on here. Okay, and then sulfur happens to be in column 6A on the periodic table. Okay, and so they have a 2- charge. They're 2 away from having that noble gas configuration, so -2. Once again, I'm so sorry, this is shaky. I'm trying my best. Okay, I'm going to crisscross my charges because I've got to balance out these charges. So I'm not changing people's charge, I'm just changing the number of everybody that I have to be able to balance out charges. You cannot just change someone's charge like this here in this scenario. Okay, we have Ni2S4. There's only one problem here, and it says it in your notes. Sorry. It says reduce to lowest common ratio. For example, in math, if you have something like this, 2 divided by 4, 2/4, that's not a fully reduced fraction, and you probably got that wrong in math class. Instead, you would have had to write 1/2, right? Remember that? Same thing happens here. We can divide both of these by 2, and this becomes NiS2. So that is technically our correct answer then. Hopefully that helps you.